Okay, and during this video, we're going to start Chapter 2, and we're going to discuss sections 1 and 2 in this video. And so some of the things that we need to take care of in Section 1 is we're going to be able to plot points associated with ordered pairs of numbers, determine whether an ordered pair of a number is a solution of an equation, graph linear equations using tables, graph nonlinear equations using tables. So when we talk about plotting a point, this is a coordinate plane, okay? And so to graph or plot points, we use two perpendicular lines called axes. And this is kind of hard to see. There's a little bitty y here, but this is going to be your y-axis. And it's hard to see this one too, and this is your x-axis. The point at which the axes cross is called the origin. So this point right here, and we label that point 0, 0. That's called the origin. Arrows on the axis indicate the positive directions. Consider the coordinate pair 2, 3. And a coordinate pair is always written with the x first and the y second. The numbers in such a pair are called coordinates. The first coordinate in this case is 2, and the second coordinate is 3. To plot the point 2, 3, we start at the origin, move 2 units horizontal, so we're going to go over 2, and we're going to go in the direction of, if it was positive 3, we're going to go up 3. If it was negative 3, we would go down 3. So I always talk about this like walking on an elevator. So if you're walking to your elevator and your point is, let's say we want to plot the point 4, negative 1. So we would walk to 4. So we walk to 4, here's 4, and then the second point tells us whether we should go up a floor, down a floor, and it's saying -1, so we would go down to -1, and that would be 4, -1. Okay, if I want to plot the point -2, 3, I'm going to walk to -2. Well, -2 is right here. Then 3 would indicate going up to 3rd floor. So this point would be the point -2, 3. Okay, so we've got some more examples of this. This says to plot the point -4, 3. So I'm going to walk to -4. Now they always start at 0, 0. It just depends on the way you want to do it. So they start at 0, 0, go to -4, and then go up to 3. I just start at the outside of the graph, walk to -4, and go up or down depending on if the number is negative or positive. So the horizontal and vertical axes divide the plane into 4 regions, and we can call that quadrants. So here's our first quadrant, our second quadrant, third quadrant, and our fourth quadrant. If you'll notice in the first quadrant, both of the numbers are positive. In the second quadrant, your x is negative, but your y is positive. In the third quadrant, both of them are negative. In the fourth quadrant, your x is positive and your y is negative. So in which quadrant is the point 3, -4 located? Well, we would go to 3, and then we would go down to -4. So it's going to sit right around in here. That's how they came up with the fourth quadrant. In which quadrant is -3, -4? So we're going to go to -3, and then we're going to go down to -4. And that's in the third quadrant. So I want to determine whether each of the following pairs is a solution of 4y plus 3x equals 18. We kind of talked about this already, but the first coordinate is x and the second coordinate is y. So I'm going to take my equation, and wherever I see a variable, I'm going to put parentheses, just leave it blank. Okay, and so to figure out if this is true, since this is 4 times y and y is equal to 3, I would put a 3 here. And 3 times x and x is equal to 2, I'm going to put a 2 here. And what I want to see is 4 times 3 plus 3 times 2 equal to 18? Well, 4 times 3 is 12, plus 6 is 18. So that is true. So this one is, the answer to this one is yes. Okay, we're going to do the same thing with this one. So I'm going to write my equation with blanks for the variable. This time they're saying x is 1. So in place of the x, I'm going to put 1. And they're saying y is 5. So in place of the y, I'm putting 5. So 4 times 5 is 20. Plus 3 times 1 is 23. And that is not true, right? So the answer to this one is no. So what that means is 2, 3 is actually on, if I were to graph this line, the point 2, 3 would be on this line. The point 1, 5 would not be on this line. Okay, so how do we go about graphing equations? They want us to graph y equals 3x, and so they pick some values for x. And so if I plug in 3 times x right here, if I say, what is 3 times 2, because they're saying x is 2, well, that value is 6. And so the coordinate would be 2, 6. So I would go to 2, go up to 6, plot that point. If I plug in a 1 here, I'm going to have 3 times 1, which is 3. So my coordinate would be 1, 3. So I went to 1, went up to 3, plotted my point. If I plug in 0, 3 times 0 is 0, so I would have a coordinate at 0, 0, which is the origin. If I plug in negative 1, 3 times negative 1 is negative 3. And so I would have a coordinate at negative 1, negative 3. So I'm going to walk to negative 1, but this time I'm going to go down to negative 3. And if I have 3 times negative 2, that's going to get me negative 6. And I'm going to go to, so I would have a point at negative 2, negative 6. So negative 2 down to negative 6. Now, I like to have, if I'm going to draw this on a test or something, I would want to kind of have a piece of paper so I can make a straight line. I'm going to try my hardest to make a straight line. But you can see that it's going to go right through these points. And I'm putting arrows on the end because it doesn't stop there. It keeps going. We would still have points past this arrow. Okay, so it's asking me to graph y equals negative 4x plus 1. So the first thing I need to do, and you don't need as many points as I had on that last one, but I'm going to pick some points. I need at least 3 just to make sure that I'm on the right track. This should make a straight line. So I picked 3 just because if one of my points is off, I'll know I've made a mistake somewhere. And I always pick something that's negative. I usually pick 0, and I pick something that's positive. And these are pretty good points to pick. Now, they won't always work. Sometimes they'll go off your graph. And if that happens, you would need to pick something smaller to make that point be on your graph. So what we're going to do is we're going to plug these in. Our y equals negative 4 times x plus 1. I'm getting that from this. And so our first, and this is going to be our coordinate value over here. So we've got negative 4. Instead of x, I'm plugging in negative 2 plus 1. Okay, and that's going to give me 8 plus 1, which is 9. And so I would have a point at negative 2, 9. Okay, next you're going to plug in, so let's do negative 4 times 0 plus 1. Well, that's just going to give me 1. So I would have a point at 0, 1. Negative 4 times, I'm sorry, we should plug in a 2 for that. Negative 4 times 2 plus 1. Well, that's going to be a negative 8 plus 1, which is negative 7. So I would have a point at 2, negative 7. So I'm going to plot my points, go to -2, go up to 9. There's 1 point. I've got a point at 0, 1, and a point at 2, -7. Now those are kind of spread out, but you can tell that they make a straight line. Let me Sometimes whenever I try to go slow, I actually make it look worse. So there's our graph of that line. Okay, so here's one. We're going to do the same thing on this one. And so I'm going to pick some numbers for x. And this one's a little bit different, right? Because we've got, it tells us to graph this, but it's not solved for anything. So the first thing I think I would do is get y by itself on this graph, and that way I can have a little bit easier time graphing this. Otherwise, I'm going to have to solve every time for y, so we don't want to do that. And so I'm going to come over here and work with this for just a minute. So I've got x plus 2y equals 6. I want to get y by itself, and that's one of the reasons why in chapter 1 we worked with this so much. So I'm going to get rid of the x. So on this side, I'm just going to have 2y, and then I'm going to have 6 take away x, and then I need to divide everything by 2. And you can leave it like this. I like to go ahead and reduce it. So 6 divided by 2 is 3, and then this is just going to be x over 2, or 1/2 times x. And that's going to make it a little bit easier for me. Okay, so I'm going to pick the same things. I'm going to do -2, 0, and 2. So when I plug this in, I'm going to have 3 minus -2 over 2. Okay, and you might want to divide first. -2 divided by 2 is -1, so this would be 3 minus -1, which is going to be 4. So 0 divided by 2 is 0, so 3 minus 0 is going to give you 3. And 3 minus 2 divided by 2, well, that's 1. So 3 minus 1 is going to give me 2. So my coordinates, -2, 4, 0, 3, 2, 2. So I'm going to go over here and plot -2 up to 4, 0, 3, and 2, 2. And I plotted 1, 2. Sorry about that. 2, 2 should be right there. So you can kind of see your straight line. It's going to continue in both directions. So what do we do with nonlinear equations? We're going to touch on this really quick. So the ones we talked about were linear. Nonlinear do not make a straight line, and so we've got the graph right here of y equals x squared minus 1. We'll talk about this later in this class, but whenever your highest exponent is an x squared, that equation is called quadratic. And it's going to make a u. And you can look at what they've done here. They plugged in 0. So I'm not going to do every single one of these, but they said y equals 0 squared minus 1, and they came up with minus 1. So that's how they got this point. When they plugged in 1, they did 1 squared minus 1. Well, that's 0. So that's how they came up with that point. They plugged in -1 next and came up with that, and they plotted those points. And they could see that it made a u, which is quadratic. Absolute value equation. These are absolute value signs. And the definition of absolute value is how far the number is away from 0. The easy way to think about it is anything inside the absolute value sign, when you solve it, it becomes positive. If it was already positive, it stays positive. And we're going to talk about that some more. But what they've done to come up with these numbers is we've got y equals the absolute value of 0 plus 3. And that gave us 3 because the absolute value of 0 is just 0. So that's how they've got the answer 3 here. Let's look at that -1. So y equals the absolute value of -1 plus 3. Well, this absolute value of -1 is just 1. It's going to give me 4, which is how they came up with this 4. And then they plotted the points. So they plugged the numbers in and plotted those points. Okay, really quick, I'm going to Okay, so really quick, I want to show you on the graphing calculator how you can come up with graphing your equation and also checking your work. So if it's solved for y equals, my graphing calculator is over here. So I'm going to kind of push the buttons over here. It should look the same as your TI-84. But if I hit y equals, it's going to bring up this screen right here. And so let's say I want to graph y equals 3, and the X button, see right beside the alpha button, this is going to be your X button, and then plus 1. We're going to graph y equals 3x plus 1. Well, if the test asks you to come up with a table, okay, so I can hit this second button, and if you'll look right above the word graph, it says table. So I'm going to hit second graph, and it pulls up this nice table. Now, I don't want my table is starting at 42, and if you remember the examples that we worked, we were looking at things that were like starting at -2 and 0. So I'm going to go over here to second window, and I'm going to say I do not want my table to start at 42. I would like for it to start at 0, and it's going to go up by 1, so that's fine. So I'm going to go back to my second graph. Second graph will get you the table, and I'm going to use my arrow keys to get back to -2. So if I plugged in -2 into that equation, y equals 3x plus 1, I would get -5. So this kind of gives you the answers. If you plug in 0, you get 1. If you plug in 2, you get 7. And so that's one way that you can use your graphing calculator to check your work. Also, if I want to look at a graph of it, I can just go over here and hit this graph button, and it'll graph it for me. Let's do one more example. Let's say I want to graph, so let's go y equals, so let's graph one of those quadratics. So I'm going to delete that out, and I'm going to say, let's do x squared plus 4. Okay, so I'm going to do x squared, so I'm going to have to type in my x first. Here's the squared button. If it was x to the third or something like that, you could use the rooftop button instead, but I'm just going to hit the x squared. And what did we say? Plus 4? Okay, so I want to get the table values for this, so I'm going to go second graph, and I can write down -2, 8, -1, 5, 0, 4, maybe some positive numbers, 1, 5, 2, and 8, and plot those points. I can also check to make sure my graph is right by looking at it, by hitting graph and looking at it. So I just wanted to take a few minutes and show you how to use the graphing calculator as far as graphing your equations. Okay, so let's talk about section 2, which is functions in their graphs, and we're going to determine whether a correspondence is a function. Given a function described by an equation, we're going to find the outputs for the specified inputs. We're going to draw the graph of a function and determine whether a graph is a function using the vertical line test, and we're going to solve some applied problems involving functions. So a function is a special kind of correspondence between two sets. The first set is called the domain, and we're talking about domain, we're actually talking about the things that you plug in for x. Okay, the domain has to do with x, and the second set is called the range, which are your y values. So your x corresponds with y. For any member of the domain, there is exactly one member of the range to which it corresponds. This kind of correspondence is called a function. Okay, so determine whether the correspondent is a function. So here's what you can recognize. If we've got 8 going to 2, that point would be 8, 2. 0 is going to 17, and -5 is going to 17. Okay, so our x's go to one value in our range. I like to explain it this way. These x's all have to be different in order for it to be a function, but the y's don't have to be different. So you're looking to see that all the x values are different, but the y values are not different. This is a function. Okay, let me show you a really quick one. So if we had, let's do this. So our domain is 8 and 0. Our range is 3, 4, and 5. So say 8 goes to 3, 8 goes to 4, 0 goes to 5. I would have the coordinates 8, 3, 8, 4, and 0, 5. All of the y's are different, but we don't care about the y's when we're trying to determine the function. We care about the x's. So are the x's all different here? No, we've got 8 listed twice. So this is an example of something that is not a function. Determine if the correspondence is a function. We've got Jackson and football. So like if we listed these as values, we would have Jackson, football. We also have Jackson and wrestling. Max, soccer, and Cade, soccer. Okay, so when we're looking at this, we're worried about what's in this first blank. Are the x's all different? We don't care about the y's, okay? Because Jackson is listed twice in the x value, this is not a function. It doesn't matter that soccer is listed twice. It only matters in the x value. Okay, a function is a correspondence between a first set called the domain and the second set called the range. Remember we talked about how domain is the x, range is the y, such that each member of the domain corresponds to exactly one member of the range. So they give some examples here. It says a set of rectangles. Each rectangle's area is a set of numbers. So the correspondent is a function because each rectangle has only one area. So it doesn't matter, all our domains would be different. We would list the rectangles different and they would all have one area that was assigned to them. Okay. If our domain is famous singers and our correspondence is a song that the singer has recorded, and our range is a set of song titles, this correspondence is not a function because some singers have recorded more than one song. So they would have more than one song listed in their list. A relation is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to at least one member of the range. Most functions are described by equations. For example, f of x is how you would read that, equals 5x plus 2, describes a function that takes an input x and multiplies it by 5 and then adds 2. So whatever is plugged into this is what you are inputting into your equation. So in this example, it says calculate the output, which is the answer, of f of 3. So they're saying plug in 3 for x. So they plugged in 3 wherever they saw x, and they found their output, which was 17. So 3 is the input, 17 is the output. So in this next example, if I want f of negative 2, I'm going to say, okay, let's find f of negative 2. Wherever I see an x in this function, I'm going to plug in negative 2. Okay, so I'm going to do, if we were doing order of operations, we would square it first. So negative 2 times negative 2 is 4 times 3. So we would get, this is 12, plus negative 6. I'm going to get 6 for our answer. Okay, this one says to figure out g of 4. So instead of t, I'm going to plug in the 4. Okay, and 6 times 4 is 24, plus 9 is 33. And so this would be my output. My input is 4. So this one says, this is a little bit more complicated, h of m plus 2, wherever they see an x, we're supposed to plug in m plus 2. So I'm going to say 8. I see an x, and m plus 2 is supposed to go there. So if we reduce that, we're going to have, use the distributive property, 8m plus 16 plus 1, which is going to end up being 8m plus 17. Okay, so h sub m plus 2 ends up being 8m plus 17. We just took m plus 2, plugged it in for x, and then simplified it. Okay, so we talked about this a little bit before, but basically we do the same thing with graphs. If you plug in a 0 for x squared, so really quickly, if I say my input is 0, which is what they're saying right here, and I go to my equation, and instead of x, I put in the 0, my answer is going to be negative 1, which is y, which is my output here. If I plug in a 1 for my input, my output's going to be 0. Same thing down here. My input is 0. If I plug it in to this equation, so if I say f of 0, I'm going to get the absolute value of 0 plus 3, which is 3. It's how they came up with their output right here. And then they plotted their points. Now, the vertical line test, if I've already got something that is graphed, the vertical line test will tell me whether it's a function or not. So if you'll look at this graph right here, and I take a vertical line, now the graph is actually the part that's drawn in black right here, that kind of looks like an S. If I take a vertical line, it's going to touch it 3 times here. Okay, and so since it touches it 3 times, it is not a function. In order for it to be a function, it would only touch it 1 time when it crossed through here. So here's an example. So if I draw a vertical line right here, it's going to hit it 1 time. If it hits it only 1 time, it is a function. Now, it has to be in any location. So this is a good example. If I draw my vertical line like right in here, that's a terrible vertical line, sorry. So if I go right here at the very edge, you might say to me, well, Miss Hill, this only hits it 1 time at that very point. But it has to happen, like if you draw a vertical line anywhere and it hits it more than once. So this one actually would hit it 1, 2, 3, 4 times if we draw a vertical line through there. This is not a function. Vertical line test, it can only hit it once if you draw a vertical line anywhere on your graph. Okay, so The following graph represents the age of an individual and their target heart rate. What is the target heart rate for a 46-year-old? That is, find f of 46. So that's what this red line, they've gone down here, 46 is halfway, a little bit over halfway in between 40 and 50. So they drew the line and they went over, because this is labeled target heart rate, and they found out that it was 130. This looks like these are going up by tens. So what if I said find f of, let's do f of 60. Okay, so we would go to 60, which is the age of the person. Okay, and then we would go over, and we'd say, oh, the target heart rate looks like this is 100, 110, 120. Okay, let's do one more. It looks like, let's do the target heart rate of somebody who is 20 years old. So we would go to our graph, go to 20, go up, over 150. And we don't need those parentheses there. Okay, so there is section 2.1 and 2.2. We'll be moving on to the next section next time.